Okay, great.
All right, wonderful. Well, thank you for coming on The Burning Question. Akio Enders, welcome to the show.
Excellent, Peter Olive. Thank you so much for having me. It's
Some
a pleasure to
context.
be here.
Yeah, well, some context. Akio has been helping me get up to speed on all things biochar. And I think he's been working on some really exciting projects both at Cornell and now as part of your PhD work. And I was curious if you could tell us both kind of what's the general scope of the project you're working on now, and kind of what's exciting about it.
So, well, very specifically, the funding is coming from the USDA to explore agricultural and dairy waste streams, specifically in New York State, to see how we can apply different thermochemical conversion pathways and technologies
Okay.
to squeeze value out of that material.
Okay. So can I?
Whether
So if I'm gonna try to do a super basic version of that, it's taking. Is it all? It's both basically cow manure and turning it into fuel and or biochar, or
well, it's all over the place, really. There are two basic flavors of thermochemical conversion that we plan to use. One is the pyrolysis, which is making char, which you're familiar with.
Yep.
And you can apply that to dry feedstock, no problem. But the issue is when you're presented with wet feedstock, well, you need to dry the moisture off, and that requires a lot of energy. So the other flavor of thermochemical conversion is what's called hydrothermal carbonization, which is it's essentially a super pressure cooker. Instead of like say 15 psi, we'll be cooking these things at 200 to maybe 3,000 psi at moderate temperatures. And these pressures are all self-generated. It's what happens when you heat this stuff up and they try to produce gases, which increases the pressure, which makes them react further, which increases the pressure, and so on. And so I'm sorry, I digress.
No, that's so I think that makes a ton of sense to me. What kind of scale are we talking about? Is this size of a car, size of a house, size of an industrial complex?
So it's interesting you should ask that question also, Peter. Because one project that I'm currently working on that I'm hoping to dovetail into the PhD, because I've already done some of the work, is this. It's the so-called mass energy balance. Well, no, let me retract two sentences. How do these chemical reactions occur at different scales, or how does the scaling affect how the pyrolysis chemistry happens? And point being, there's this instrument, the thermogravimetric analyzer, which is like a tiny little furnace, right?
Yeah.
It's a tiny little furnace with a very sensitive scale, and you get to program this temperature environment. So basically you put 10 milligrams of sawdust in the little pan, and you're flowing nitrogen, and you heat it from ambient to 105, and then the weight loss is moisture, and then you're still under nitrogen, and you heat it at 5 degrees or 50 degrees a minute to 700 degrees, and you're pyrolyzing and you're making char. So anyway, what happens in a TGA is not what happens in a full-scale kiln. Right. And there's a lot of papers in the literature about look at all these TGA experiments. Well, you know what? That's great. That was really convenient
Hmm.
because you've got small sample sizes and you can automate it and get lots of data. But this is not what happens in the real world.
Hmm.
So, at any rate, I think one piece of research that I'm looking forward to is just kind of describing how conventional pyrolysis, how the chemistry changes as you move from milligrams to hundreds of grams to kilograms in a continuous unit.
Hmm.
Um, so, and then otherwise, these other hydrothermal carbonization versus pyrolysis experiments, I expect that to be mid-scale, lab
Yeah.
size,
And so,
single-digit liters.
yeah. So can you give me an idea of kind of the scope and timeline for something like this? I think like the end goal is essentially process um, dairy manure into something we could use. And first you have to do the
So, okay,
tiny version. But how does this all work? Are we talking 5 years?
well,
Are we talking 2 years? Are we talking?
um,
Is it happening now?
the the scope of the grant is defined as 3 years,
Hmm.
which means I need to get this together immediately. Um,
This
and
is the end of this
part of
interview.
yeah, I gotta go. No, so part of this is just quantifying these wastes in New York State. So, okay, there's so many cows, there's so many dairy cows. How much dairy manure is that? What portion of that is already going to be collected into an anaerobic digester system where there's already some hardware where we could get the solids or the screw press dry solids versus the liquids or whatever. Um, Otherwise, the other major New York agricultural crops, well, we've got apples.
Hmm.
Um, so let's quantify apple pomace, the leftovers from processing to make cider,
Hmm.
because that's another a potential waste feedstock.
That's
Um,
that's wet and therefore appropriate for the kind of work you're doing.
you're right. It is.
Yeah.
That's perfect for the hydrothermal carbonization super pressure cooker
I feel like the
flavor of
dis
pyrolysis. So,
I feel like the
hmm?
discrepancy between the like how smelly each process would be from dairy manure and apples, I feel is like those are the ends of the spectrum.
Yeah.
It's like
Well,
apple pie.
right. I mean, the for what it's worth, the pressure cooker is a closed vessel, so you're not going to smell any poo.
I
But
imagine so.
I do have some experience shoveling a pickup truck worth of dairy manure on a concrete floor every day to make sure it dries out nice and quickly. Um, so, all right, to answer your questions, yeah, the timeline is 3 years. Um, what's the goal? Well, it's to be able to, I don't know, to wrap some numbers, to make a case for, all right, you know what? This is if you collect dairy manure, you can treat it this way. You could, wet process and then filter your carbonaceous stuff out of there, and then potentially pyrolyze that further.
Mhm.
Or there's the wet process, and then oh my goodness, so much of the phosphorus comes out in the liquid fraction. Well, then you could do something with that.
Mhm.
So it's to come up with engineering solutions for several of these characteristic New York State waste stream feedstocks. How can thermochemical conversion, oh, here's the word, valorize.
Oh, here we go. Okay, great. We're making
Um,
money. Now we're
right.
making money.
Well, right. And,
Yeah.
there's all sorts of value that um, the dollar signs aren't slapped onto, like
Yeah.
avoiding pollution.
And so from
Um,
a like a perspective of the work writ large, is it about like is there a specific target? It's like, okay, we want to reduce effluent in the water system. We want to recover uh, nutrients. We want to, is it all that stuff, or is there a specific
yes,
thing?
it is all of
It's
it.
all of it. Okay.
Which that's really fortunate that the grant. is written in that way to give us some flexibility to say, listen, hey, here's all these different awesome things that you can do. And this is not commercialization, but this would hopefully inform commercialization enough that it would happen.
Right. So when I think about solving these kinds of problems, specifically around biochar, it's kind of like the first question is almost always a feedstock question, like can you get any of the thing that you want to burn? And then the second one is almost always a technical question, which is like, how do you burn it and does it work? And that's kind of, it sounds like that's where you are now.
Yes.
Yeah.
And I should interject, and burn is a dirty word.
I'm sorry.
In so much as we're not burning the wood. We're not burning the wood to make char, we're pyrolyzing it, or we're charring it.
Yes. Okay. I can update my language here. Thank you.
Because otherwise, yeah, it's just straight to CO2.
Right. Okay. Well, so then, best case scenario, this goes really well. You guys figure out the machinery to make this work. Kind of, what are we looking at? Is this something? I have no idea of the scale of kind of dairies or dairy waste. Is this? Does this a good thing just for the earth for avoiding all the things we just described, avoiding recovering nutrients and avoiding effluent in the waterways and so on? Or is this something you could actually use to like sequester carbon and do that kind of
thing? Well, certainly if you're pyrolyzing or carbonizing any of this organic stuff, yes, it is a carbon sequestration tool. You are sequestering carbon. The question is for how long, which is really, how solid is the carbon or how stable is the carbon? Because, hey, a tree is sequestering carbon, but, so many decades after that thing falls over, it didn't really.
It's not there anymore.
Back in the atmosphere.
Right.
So what scale? That would be an engineering question that may or may not be part of that particular thesis. I think that's kind of beyond the scope.
Yeah.
But I think, if you're able to make a case for, say, all right, well, there are these CAFOs, these concentrated animal feeding operations. And because of New York state law, each of these operations that has more than so many cattle, sorry, I don't know this, cows rather, they need to have an anaerobic digester. So, okay, great. That infrastructure is in place already. Let's see how we can piggyback on that. And oh my goodness, well, because they have an anaerobic digester, they also have something to combust the methane that's generated in, or they have some way to compress the methane or send it down the pipeline or something like that,
Right.
So there will already be infrastructure that that could benefit the valorization of some of these thermochemical pathways. Did that answer?
Great. That's exciting. I mean, considering how many cattle I assume are in the United States, it's got to be, I don't know, tens or hundreds of millions, maybe more.
And as it's the question comes down to transportation a lot of times.
Right.
And if this is a great thing to do, and you're spending all this fuel to collect the poo from each individual cow, well, then it's kind of a non-starter, you know.
Yeah.
Yeah.
Well, that sounds like a super interesting project. So where are you going to be doing the project? How can we follow along? Are there fun things that we could learn, before 3 years are up?
Well, most certainly. I know on my timeline, I've got, conferences that I will be speaking at, and, I'll have an outreach event, and I'll be sure to let you know.
Yeah, let us know about that stuff. We'll share it out.
And otherwise, I start in August. Luckily, I was given a bit of funding so I could just spend some time on this and get my feet under me so I could hit the ground running in August. So yes, details to follow.
Well, that's great. Well, we look forward to hearing more. As soon as you have more interesting stuff to share, feel free to come back on the show or just give me a call. Uh,
Sure.
and then